All right, today we're going to be looking at the notes for Unit 3.5, which is all about segment proofs. Just a reminder, we started off talking yesterday about all these properties of equality. It's very important for you to learn all those and how they work. But the thing to know about the properties of equality is they only work whenever we have equal signs, not congruent symbols. All right, so the properties of congruence are the ones that we can use with congruent symbols. So these properties of congruence we will look at now. So the first property we're going to look at is the reflexive property of congruence. And the reflexive property of congruence is very similar to the reflexive property of equality. And that just says that for any segment AB, we would say segment AB is congruent to segment AB. That's kind of like an obvious one, but hopefully that makes sense. That is the reflexive property. Next, we're going to look at the symmetric property, and that's also very similar to what we had with the symmetric property of equality. So if segment AB is congruent to segment CD, then segment CD is congruent to segment AB. So it basically just allows us to flip sides of the congruent symbol. So if it was on the left, now it can be on the right, and vice versa. The transitive property, that is one that we're going to use quite a bit in segment proofs. That says that if segment AB is congruent to segment BC, and segment BC is congruent to segment CD, then segment AB is congruent to segment CD. All right. So it's kind of like if segment A is congruent to segment B is congruent to segment C, then segment A is congruent to segment C. So another way of thinking about it. All right, so definition of congruence. Segments are congruent if and only if they have the same measure. So if segment AB is congruent to, actually let's work the other way around. Start with the other way. So if the measure of AB is equal to the measure of CD, that means that segment AB is congruent to segment CD. And that works the other way around. This is what I was going to do the first time. If segment AB is congruent to segment CD, then we could say that AB is equal to CD. So kind of what proves to what congruence means is that if the two things are the same length, two segments are the same length, they are congruent. And if two segments are congruent, then they have the same length. So it's just kind of interchangeable how that property works. Works both ways. Next, definition of a midpoint. The midpoint of a segment divides a segment into two congruent parts, and they are equal parts. If M is the midpoint of segment AB, then we could say that segment AM is congruent to segment MB. We could also write that as AM equals MB. All right, so those mean the same thing. That is the definition of a midpoint. So anytime we see the word midpoint, or we see that two halves of a segment are equal to each other, then we're going to assume that we're going to use definition of midpoint. All right, the last thing is a postulate, and this postulate we have used already this year, back in Unit 1, Module 1, and that's the segment addition postulate. So if A, B, and C are collinear, so they're all on the same line, and point B is between points A and C, then we can assume that AB, segment AB, the measure of segment AB, plus the measure of segment BC is equal to the measure of segment AC. So part AB plus the part of BC, you add those together, you could get the whole of AC. All right, so what I want you to do now is pause this video for a few minutes and work on trying to figure out these 14 fill in the blanks on your own. After you're done working on them, then unpause and come back and we'll go over them together. All right, I hope you had a good opportunity there to pause the video and work through this list. So let's look at this together. If PQ equals PQ, then segment PQ is congruent to segment PQ. That is switching from a equal sign to a congruent sign is the definition of congruence. All right, next, if K is between J and L, then JK plus KL is equal to JL. That is the segment addition postulate. Segment EF is congruent to segment EF. That is the reflexive property. Of congruence. If RS is equal to TU, then RS plus XY is equal to TU plus XY. Well, we're adding an XY to both sides, so that is the addition property. If AB equals DE, then DE equals AB. That is the symmetric property. That's what allows us, and that is the symmetric property of equality. That's what allows us to switch what's on the left side of the equal sign to what's on the right, and vice versa. If y is the midpoint of xz, segment xz, then xy is equal to yz. That is the definition of a midpoint. All right, if segment FG is equal to segment HI, congruent to segment HI, and segment HI is congruent to segment JK, then segment FG is congruent to segment JK. That is the transitive property of congruence. All right, so if AB plus CD equals EF plus CD, then we can assume that AB is equal to EF, and we can assume that because we can subtract the CD off of both sides, so that is the subtraction property. If PQ plus RS is equal to TV, and RS is equal to WX, then PQ plus WX equals TV. Well, we were able to substitute in what RS was equal to, which is WX, so that is the substitution property. Number 10, if LP equals PN, and points LP and N are collinear, then P is the midpoint of segment LN, and that is the definition of a midpoint. And anytime we see the word midpoint, always want to start with, is that a definition of a midpoint? Assume that's where they're wanting you to go. At some point, we're going to use that probably, so start thinking that direction. If segment UV is congruent to segment UV, then the measure of UV is equal to the measure of UV. So that is the definition of congruence. That's what allows us to switch from congruent symbol to an equal sign. So if CD plus DE is equal to CE, then CD is equal to CE minus DE. Well, what we have done is we have subtracted a DE off of both sides, and so that is the subtraction property. If 2xy equals xz, then xy is equal to a half of xz. All right, this one we have divided both sides by 2, so that is the division property. And then this last one, if RS is equal to ST and ST equals 2UV, then RS equals 2UV. Again, this one is one of those that could go different directions. I'm leaning towards the transitive property. But I can also accept substitution property. But really leaning towards transitive. I really like that one better there. All right, so now let's look at some sample proofs. We just have a few here. All right, so given that E is the midpoint of segment DF, prove that 2DE is equal to DF. Okay? So the first thing we have is that E is the midpoint of DF, and that is a given. So that's the reason for that. Then as we look, E is the midpoint of DF. The next statement it says is DE is equal to EF. Well, I know that is true because E is the midpoint. That means that from D to E is going to be equal to E to F. So that is the definition of a midpoint. Then if we look here at number 3, we're going from DE equals EF to DE plus DE is equal to DE plus EF. We're adding a DE to both sides. All right, so DE, adding a DE to both sides, that means that we are using the addition property. Addition property says I can add anything I want as long as I add it to both sides. Addition property. Next, we have 2DE is equal to DE plus EF. So all I've done there is just clean that up. DE plus DE, that just means there's 2 DEs. So that's just simplifying. Number 5 here has more to do with the picture of the line than necessarily with number 4. Number 5 is just saying that segment DE, the measure of that, plus the measure of EF, when you add those together, you get from D to F. That is the segment addition property. And then this last one here, this one, think about it this way. If 2DE, we have that there. We have DE plus EF goes there. And we have DF goes there. So if the black is equal to the red and the red is equal to the blue, therefore the black is equal to the blue, that is the transitive property. All right. So moving on to number 2 here. Segment KL is congruent to segment LN. So let's go ahead and mark that up. And then we have segment LM is congruent to segment LN. So mark that up as well, congruent to LN. And as we move down here to the reasons, that is what is given. Now, if you look at between step 1 and step 2, the only thing that's different is that we're now talking about the measures of those things instead of being the shape being congruent, the measures are equal. So that is the definition of congruence. All right. So now the next statement is that KL is equal to LM. So KL is equal to LM, and I can make that statement based on the transitive property. Again, if the black line is equal to the red line, and the blue line is equal to the red line, therefore the black line is equal to the blue line. So that, again, is the transitive property. And then lastly, L is the midpoint of KM. Well, that's the definition of a midpoint, that since the two segments are congruent, they're equal to each other. That means L is halfway between K and M, so that is the definition of midpoint. All right, last one here, number 3. We are given that line PQ is congruent to line TQ. So I'm going to go ahead and put a tick mark there. We're also told that line UQ is congruent to line QS. I'm going to put 2 tick marks there because I don't know if PQ is congruent to QU or UQ, but I know that UQ is congruent to QS and PQ is congruent to TQ. All right, so that is what is given to us. Next thing we're going to do, you see we just switched from congruent signs to equal signs. So that is the definition of congruence. Okay. The next thing I have is PQ plus QS equals PS. And I also have TQ plus QU equals TU. Well, again, that's just saying that these two segments, when you add them together, equal the whole thing. 2 parts equal the whole. So that is the angle, or not the angle, that's next class. Segment addition postulate. Okay, so I know that PQ is equal to TQ. And I also know that PQ plus QS equals PS. So what if I substituted in TQ for PQ? Then I would have TQ plus QS equals PS. So that would be the substitution property. Okay, so TQ plus QS equals PS. And TQ plus QS equals TU. So again, substituting in, I know that TQ plus QU equals TU, and I know that QU is equal to QS, so I can substitute in a QS for that QU. So again, that is substitution property. Okay, so now, because TQ plus QS is equal to PS and TQ plus QS is equal to TU, I can say that PS is equal to TU. Again, black line is equal to the red line, black line is equal to the blue line, therefore the red line is equal to the blue line. So that is the transitive property. And that proves, therefore, that segment PS is congruent to segment TU because, again, that is the definition of congruence. All right, that's it for today. If you have any questions, please shoot me an email or a Canvas message, and I'll get back to you as soon as I can. Have a great day.